Are we truly alone in this universe? Or is there someone, somewhere far away, also watching Earth and asking the same question? Recently, the James Webb Telescope has brought a promising discovery. Exoplanet K 218b, located 120 light-years away, contains traces of CO2, methane, and a molecule potentially linked to life, dimethyl sulfide. This could be a monumental turning point in the search for extraterrestrial life. The journey to explore the universe never stops. From nearby planets and mysterious signals to cutting-edge technologies gradually unveiling the cosmos's secrets. Today, we will delve deep into the quest for extraterrestrial life. Part 1. Strategies for searching for life. Scientists are employing various strategies to search for signs of life. However, life does not necessarily mean advanced civilizations like those in science fiction. It could be bacteria, microorganisms, or even life forms beyond our imagination. Strategy 1. Searching within the solar system. Our solar system contains several promising candidates for the search for life, places where the necessary conditions for life may exist. Mars, the red planet. Mars has long been a prime target in the search for extraterrestrial life. Scientists have discovered traces of ancient riverbeds on its surface, suggesting that Mars once had liquid water, an essential ingredient for life. NASA's rovers, such as Curiosity and Perseverance, are actively searching for signs of ancient microorganisms in the Martian soil and rock layers. One particularly intriguing discovery is the presence of methane in Mars's atmosphere. On Earth, most methane is produced by living organisms. If the methane on Mars also has a biological origin, it would be a significant breakthrough in confirming extraterrestrial life. Beyond surface exploration, NASA is developing the Mars Sample Return mission in collaboration with the European Space Agency, ESA, to collect Martian soil samples and return them to Earth for laboratory analysis. Studying these samples suggests that Europa has hydrothermal vents on its ocean floor, providing the necessary energy for life to exist. NASA's Europa Clipper mission, scheduled for launch in 2024, will perform multiple flybys of Europa to study the chemical composition of its hidden ocean. NASA is also considering deploying a robotic submarine capable of drilling through Europa's thick ice to reach the subsurface ocean and search for signs of microbial life in the liquid water. Enceladus, moon of Saturn. Saturn's moon. Enceladus also harbors a subsurface ocean, confirmed by the Cassini spacecraft, which detected geysers erupting from its surface. These plumes contain organic compounds, salts, and hydrogen key ingredients for life. The proposed Enceladus LifeFinder mission aims to send a probe through these plumes to analyze their chemical composition in greater detail, determining whether microorganisms might exist in this hidden ocean. Strategy 2. Detecting exoplanets. The search for life is not limited to our solar system. Scientists are focusing on exoplanets, planets outside our solar system that could have conditions suitable for life. Kepler and James Webb Space Telescopes. The Kepler Space Telescope was a pioneering instrument in discovering exoplanets. From 2009 to 2018, Kepler identified over 5,000 exoplanets, including hundreds located in habitable zones. Kepler used the transit method, detecting dips in a star's brightness as a planet passed in front of it. Following Kepler, the James Webb Space Telescope, JWST, continues the mission with more advanced technology, allowing scientists to analyze exoplanetary atmospheres. A significant breakthrough from JWST was the detection of atmospheric components on K218b, an exoplanet containing traces of water vapor, CO2, and methane key elements for life. Beyond K218b, JWST is also studying other exoplanets such as LHS 1140b and TOI 700d, which are believed to have conditions suitable for sustaining liquid water. Using transmission spectroscopy, JWST observes starlight passing through a planet's atmosphere to identify potential biosignatures like ozone, oxygen, or complex organic molecules. The data collected by JWST will be crucial in determining whether life exists beyond Earth. ESA's aerial mission. The European Space Agency, ESA, is planning the Ariel mission, Atmospheric Remote Sensing Infrared Exoplanet Large Survey, scheduled for launch in 2029. Ariel aims to analyze the atmospheres of over 1,000 exoplanets, searching for chemical signatures of life and understanding their environmental conditions. Ariel will measure infrared and optical spectra from exoplanets, identifying key compounds such as water vapor, H2O, carbon dioxide, CO2, methane, CH4, ammonia, NH3, and complex organic molecules. Ariel will focus on warm and hot planets, including super-Earths, mini-Neptunes, and gas giants within habitable zones. In addition to searching for biosignatures, Ariel will help scientists understand how planets form and evolve, broadening our knowledge of planetary diversity across the galaxy. A key advantage of Ariel is its ability to conduct large-scale observations, creating a standardized data set on exoplanet atmospheres. This data will not only support the search for extraterrestrial life, but also allow comparisons between exoplanets and Earth. Together with JWST and future missions such as Plato, ESA, and TESS, NASA, Ariel will provide a comprehensive picture of exoplanets, bringing humanity closer to answering whether life exists elsewhere in the universe. The TRAPPIST-1 system. One of the most fascinating planetary systems is TRAPPIST-1, located 40 light-years away in the Aquarius constellation. Discovered in 2017 by NASA's Spitzer telescope, TRAPPIST-1 consists of 7 Earth-sized planets, 3 of which are within the habitable zone: TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g. Structure and characteristics of the TRAPPIST-1 system. All 7 planets orbit a small, ultra-cool red dwarf star, which has a radius only about 9% that of the Sun. One unique characteristic of TRAPPIST-1 is that all its planets are in close proximity to the star, resulting in short orbital periods ranging from just a few days to a few weeks. While this means they are exposed to strong stellar radiation, it also makes them ideal candidates for atmospheric studies using transmission spectroscopy. Key discoveries about TRAPPIST-1. Observations from the Hubble and James Webb. Space telescopes suggest that some TRAPPIST-1 planets may retain atmospheres, increasing the likelihood of liquid water on their surfaces. A 2023 study using JWST detected CO2 and CH4 in the atmosphere of TRAPPIST-1d, hinting at potential chemical processes conducive to life. However, these planets also face strong radiation from their host star, which could strip away their atmospheres unless they have strong magnetic fields. JWST continues to monitor the TRAPPIST-1 system to further refine atmospheric composition data. In the future, missions like Ariel, ESA, and LUVOIR, NASA, will conduct even more detailed analyses, potentially imaging the surface of TRAPPIST-1 EUE to search for biosignatures. If gases like O2, O3, or CH4 are found in its atmosphere, it would be a significant step toward confirming extraterrestrial life. Strategy 3. Listening for signals from alien civilizations. Beyond searching for biosignatures, scientists also use radio telescopes to detect potential signals from advanced extraterrestrial civilizations. SETI, Search for Extraterrestrial Intelligence. SETI, Search for Extraterrestrial Intelligence, is a scientific initiative that scans the sky for artificial radio and optical signals. The project operates under the assumption that if intelligent extraterrestrial civilizations exist, they might transmit signals that we could detect. SETI utilizes powerful radio telescopes such as the Green Bank Telescope, USA, and Allen Telescope Array, ATA, to analyze billions of signals daily. One of the most famous events in SETI's history is the WOW signal, detected in 1977, which remains unexplained to this day. Modern SETI projects integrate artificial intelligence, AI, and advanced data processing algorithms to filter noise and improve accuracy in detecting signals from distant civilizations. Additionally, Breakthrough Listen, a $100 million initiative, is expanding the search to include hundreds of star systems with potentially habitable exoplanets using AI-driven data analysis. Part 2. Crucial experiments. Viking 1 and Viking 2. the search for life on Mars. In 1976, NASA launched the Viking 1 and Viking 2, two landers to Mars, marking humanity's first attempt to conduct biological experiments on another planet. These landers performed 3 key experiments designed to detect microbial life in the Martian soil. One of these, the labeled release LR experiment, yielded positive results, suggesting biological activity. However, the other 2 experiments did not confirm this finding, leading to decades of debate about whether Martian bacteria existed. Some scientists propose that the testing methods might not have been suitable for Mars's extreme conditions, possibly preventing any microbes from surviving the experiments. Today, missions like Curiosity and Perseverance continue to study Mars's soil chemistry. Recent discoveries of complex organic molecules have reignited hope that life may have once existed or still exists beneath the planet's surface. To obtain more definitive answers, the Mars Sample Return Project is being developed to bring Martian samples back to Earth for more detailed analysis. The ALH-84001 experiment, a Martian meteorite with possible fossilized life. In 1996, a NASA research team announced a groundbreaking discovery: possible fossilized microbial structures in a Martian meteorite known as ALH-84001, which crashed into Antarctica around 13,000 years ago. Scientists found nanometer-sized tubular structures, organic compounds, and magnetic minerals in the rock, sparking the hypothesis that they could be remnants of ancient Martian life from billions of years ago. However, subsequent studies suggested that these features might have formed through non-biological processes. Despite this, ALH-84001 remains a crucial piece of evidence that supports the possibility that Mars once had conditions suitable for life. This discovery also helped shape the objectives of modern Mars missions like Curiosity, Perseverance, and the upcoming Mars Sample Return Project. Mars Sample Return, bringing Martian soil to Earth. The Mars Sample Return mission, a joint effort between NASA and ESA, is one of the most ambitious projects aimed at retrieving soil and rock samples from Mars and bringing them to Earth for extensive laboratory analysis. This will mark the first time humanity directly studies materials from another planet. Currently, NASA's Perseverance rover is collecting and sealing Martian soil samples in specialized tubes, designed to withstand Mars's harsh conditions until a retrieval spacecraft arrives. Around 2030, a spacecraft will be launched to collect these samples and return them to Earth. Scientists will analyze them with state-of-the-art instruments to search for ancient biosignatures, organic compounds, and investigate Mars' geological history. If microbial fossils or biochemical traces of life are found, this could be one of the greatest scientific discoveries of all time. Additionally, the Mars Sample Return Project will provide valuable data for future human missions to Mars, helping researchers better understand the planet's environment and potential for long-term human settlement. Experiments on Europa and Enceladus, searching for life in subsurface oceans. Moons such as Europa, Jupiter, and Enceladus, Saturn, are believed to host vast subsurface oceans beneath their icy crusts. Data from NASA's Galileo and Cassini spacecraft provided strong evidence that geysers erupting from Enceladus contain organic compounds, salts, and hydrogen essential ingredients for life. NASA's Europa Clipper mission, scheduled for launch in 2024, will conduct detailed scans of Europa using ice-penetrating radar to determine the thickness of its ice crust and detect chemical signatures in its hidden ocean. Scientists are also developing concepts for an autonomous submarine robot capable of drilling through Europa's thick ice shell to reach its ocean and search for microbial life in the liquid water. If successful, such a mission could provide the first direct evidence of extraterrestrial life in our solar system. Future collaborations with telescopes like LUVOIR, NASA, and SKA, Square Kilometer Array, will significantly improve SETI's ability to detect extraterrestrial intelligence. Breakthrough Starshot, sending nano spacecraft to Alpha Centauri. One of the boldest initiatives in the search for extraterrestrial life is Breakthrough Starshot, an ambitious project aiming to send ultra-small spacecraft to Alpha Centauri, the closest star system to Earth, located 4.37 light-years away. This project proposes using light sail technology, in which a miniature spacecraft attached to an ultra-thin sail is propelled to 20% of the speed of light by a high-powered laser beam from Earth. The sail, just a few meters in size, is designed to absorb energy from the laser and accelerate the spacecraft to unprecedented speeds. If successful, the spacecraft could reach Alpha Centauri in just 20 years, compared to tens of thousands of years with conventional propulsion. Upon arrival, it would capture images and gather data from planets within the system, particularly Proxima b, an exoplanet in the habitable zone of Proxima Centauri. Breakthrough Starshot could revolutionize interstellar exploration and pave the way for future missions capable of deeper space travel. Finally, imagine a day when the world is shaken by the news. NASA confirms the discovery of extraterrestrial life. How would you feel? Excited, thrilled, or perhaps anxious about the unknown? Share your thoughts in the comments, and don't forget to subscribe to our channel for more exciting discoveries about the universe.